Okay, I was trying to explain the variables, Abby. I was trying to explain the variables. Okay, so I saw the variable not done. So independent variable, dependent variable, explanatory variable. So all the mal like interchangeably. So it's not a problem. So leaving that, let's now talk about other things tó wà nínú. Mo kàn ṣáà sọ oríṣiríṣi nǹkan tó lè jẹyọ bí a ṣe ń bí a ṣe ń kọ́ ẹ̀kọ́ yẹn lọ. So anything that is similar. So here, specification of mathematical model, ìbẹ̀rẹ̀ tí máa kọ kíní kan is the function of kíní kan, then y is equal to b1. Ẹ mọ̀, tẹ́ bá ń kọ mathematical equation normally, y is equal to mx plus c, like normally, y is equal to mx plus, that is like how to write a linear equation. So tá bá kọ y is equal to mx plus c, right? Tá bá fi gbé y is equal to b1 plus b2x. Kí wá ni m? Exactly. So which is same as the b2. Nínú equation tó wà ní number 2 tá à ń sọ̀rọ̀ lé lórí ẹ̀ yìí. Then the c constant term ó máa jẹ́ b1. So like that's just the adoption of this thing. So when you are now done with that, a máa lọ sí number 3, which is the specification of econometric model. So for econometric model, òun ni wọ́n ti fi sí ibi báyìí. Ẹ máa add u, small u àbí small e. Ìtumọ̀ u yẹn ni pé error term la máa ń pè é. Error term. Now, error term ní oríṣi iṣẹ́ tó ń ṣe, in the sense that by the time tí ẹ̀ bá padà ṣe regression, result yẹn kò kí ń jẹ́ perfect result. Kò ń jẹ́ perfect result. So every other thing tí ó jẹ́ kí result yẹn kó perfect bó ti yẹ kó ṣe perfect, òun ló wà nínú error term yẹn. So that is why we say that econometric models, they are not deterministic. Econometric models are not deterministic. Let me write that. Econometric models are not deterministic. They are stochastic in nature. So stochastic, I'm mark it here. Stochastic in nature. So kí ni ìtumọ̀ not deterministic? So ẹ lè ní something like fún econometrics, ẹ lè ní something like q is equal to 40 minus 3p. Bá ṣe ṣe example lẹ́ẹ̀kan yẹn. So kò ní rí báyìí. So it's going to like q is equal to 40 minus 3p plus u, which is the error term. Because what we are trying to do ni pé a mọ̀ pé okay o, things are not like exactly the same thing. So okay, ká ṣe àpèjúwe. Tí ẹ bá increase income mi by 10,000. So when increase income mi by 10,000, normally we should buy more of a particular good. Like of a normal good. If I go normal good and cost, we should buy more of those goods. But but the way we are going to respond, you may buy more, I may not buy more. In fact, I may save all my money, right? So at the end of the day, get equation ò ní jẹ́ perfect equation. So that's what we are saying, because you are trying to like find the average of different kind of behaviors. So it's not going to be a perfect thing. So the imperfection is now what is being captured in the error term. Òní yìí yẹn fi wọ́n bẹ́ẹ̀ pé ó ṣì máa láwọn behavior nǹkan tá à ń try àti ẹ̀ ṣàlàyé tí a really capture tán, right? Then the error term is also there as a result of the fact that kì í ṣe price nìkan ló affect the quantity demanded. There are also other variables. Income yín affect ẹ̀, taste yín affect ẹ̀, bóyá trend ní nǹkan, bóyá trend ló yẹ kẹ́ ẹ rà gan, ó wà, bóyá peer pressure ló yẹ kẹ́ ẹ rà, ó wà ń bẹ̀. So all of those variables still were captured in the model, because in the model tá nísìn, we only have one independent variable, which is price. So all of those things that are not captured in this model, right, they are also captured in the error term. So the fact that you have a u means that it is ìtumọ̀ stochastic nìyẹn, because only it is like only láti ṣe pẹ̀lú probability. But èyí tí mo kọ́kọ́ kọ q is equal to 40 minus 3p, ìyẹn ò ní kankan ṣe láti pẹ̀lú probability, it is exact. Okay, that being said, So we now go into one equation to talk us number 3 yẹn pé okay y is equal to b1 plus b2x plus u error term. So another name for the error term is also called the disturbance term, and it's also called stochastic term or the random variable. Disturbance term, the stochastic term, or the random variable. So let me even read the whole thing. The purely mathematical model of the consumption function given in equation 1 is of limited interest to econometrician, for it assures that there is an exact or deterministic relationship between consumption and income. Ìgbà tá a ṣe gbogbo national income tá a ṣe ní macro yẹn, consumption is a function of income, q is a function, c is a function of y. Àwa kọ pé c is equal to a plus byd tá a ṣe ń gbà tí ibi tí yd ti jẹ́ disposable income. Tá a bá fílẹ̀ bẹ́ẹ̀, that is a deterministic relationship, so it is exact. So after ti sọ pé gbogbo nǹkan tó ń ṣẹlẹ̀ sí consumption is based on gbogbo nǹkan tó ń ṣẹlẹ̀ sí disposable income, but that may not be true. Now, but relationships between economic variables are generally inexact. Thus, if you obtain data on consumption expenditure and disposable income of a sample of say 500 Nigerian families and plot this data on a graph paper with consumption expenditure on the vertical axis and disposable income on the horizontal axis, we would not expect all 500 observations to lie exactly on a straight line of equation 1 above, because in addition to income, other variables affect consumption expenditure. For example, the size of the family, the ages of the variables, the ages of the members in the family religion, etc., are likely to exert some influence on consumption. So to allow for the inexact relationship between economic variables, the econometrician would modify the deterministic consumption function in equation 1 as follows. So instead of kakọ ní y is equal to b1 plus b2x, a máa ní y is equal to b1 plus b2x plus u. So níbí báyìí sìn, y is serving as a consumption variable, x is serving as the income, u is the error term or the random term or the stochastic term or whatever they want to call it, or the disturbance term. So where u known as the disturbance or error term or random stochastic variable that has well-defined probabilistic properties. The disturbance term may well represent all those factors that affect consumption but are not taken into account explicitly. So mo ti sọ yẹn náà pé gbogbo àwọn other variables tó lè máa affect the regressand or the explained variable wọ́n máa captured nínú error term yẹn. So we are not expecting our result to be like exact. Okay, when there is an 100% changes in like consumption, we expect everybody to behave the same way ní gbogbo data that you collect láti gbà. Àwọn èèyàn ní behave the same way for different reasons. Now, when we are now done, so mo fẹ́ kẹ́ summarize láì wo ìwé yín, mi sọ pé ẹ̀ ń jíwèé wò bọ̀ láì wo ìwé yín, kí ni àwọn 3 traditional methods in their sequence, like in sequential order, tí econometrician máa ń lò. Irọ́ ẹ mọ̀ ọ́n gbogbo ọ̀tá tí ń sọ láti bẹ̀rẹ̀ ni ẹ mọ̀ ọ́n, ẹ má wà shy. So ẹ kàn fi style bá wa sọ. Mẹ́jọ ni wọ́n, a ti ṣàlàyé mẹ́ta, so àwọn mẹ́ta yẹn mo kàn fẹ́ kẹ́ sọ láti bẹ̀rẹ̀ like lẹ́sẹẹsẹ like step by step. Can you, it's okay. Number 1. Specification of mathematical model lásán. So tó bá pé consumption lẹ wá ń wò, tá consumption lẹ wá ń wò lẹ máa sọ pé of consumption. Specification of mathematical model. Torí consumption làwọn ń wò, like consumption la fi ń ṣe example. So ó lè jẹ́ demand lóyin máa fẹ́ ṣàlàyé at another period. So just mathematical specification of model. Ẹ máa la àwọn kí nínú project yín àbẹ́ kí n kọ́ project. Gbogbo àwọn bẹ́ẹ̀ ṣe ń kọ́ lẹ́ẹ̀kọ̀ọ̀kan náà lè máa lò. Tí bá ti sọ pé mo fẹ́ relationship between this and this and this, project topic yín nìyẹn. Tí bá ti ń ṣe methodology yín, so ẹ máa bẹ̀rẹ̀ sí ẹ máa kọ́kọ́ mathematical model, ìyẹn ni kò kí ń ní u. Then from there you now go into your econometric model, ìyẹn ló máa ní u. So gbogbo nǹkan tá à ń kọ́ sí gbogbo nǹkan tẹ́ máa ṣe nínú kíní kí lẹ́yìn pé project yín náà nìyẹn, so like kẹ́ ṣáà máa understand bó jẹ́ pé máa padà bóyá pé máa padà gbé fún yàn náà ni, but at least nǹkan tẹ́ni ẹ bá ṣe kó ṣàyè yín. So that's this thing. So the next one is the specification of which model now? Jíwèé yín wò. Statistical or economic? Ṣé economic model àbí econometric model? Kò yẹ kó jẹ́ economic model. So ìyẹn ló máa ń ní U, which is the error term. It's not hard. It's not hard. Error term, stochastic term, random variable, disturbance term. So when you're now done with that, tó bá ní bókè o lọ kọ chapter 4 ẹ̀ wá fún project, irú àwọn nǹkan tí wọ́n ń béèrè nìyẹn. So ẹ máa ṣe wá ṣe number 4 náà, obtaining data. Ní chapter 4 ẹ̀ ṣì máa padà kọ́ náà síbẹ̀ pé o ibi báyìí báyìí ni mo ti expect pé mo ti máa gba data mi o, bóyá máa gbà láti World Bank, máa gbà láti National Bureau of Statistics, máa gbà látọwọ́ CBN, kíníkan. So ẹ máa sọ bó ti fẹ́ gba data yẹn, bẹ́ẹ̀ máa kọ́ sí project yìí náà nìyẹn. Irú variable náà dẹ̀ lẹ fẹ́ gba, irú data náà lẹ fẹ́ gbà. Kí máa gba data lórí GDP, máa gba data lórí èlé, máa gba data lórí unemployment. Ẹ tún máa sọ scope yín náà. Okay, data mi máa jẹ́ from this year to this year. Nǹkan tó ń pè ní scope nìyẹn. Scope is just time period. From this year to that year. So like that's just it. So number 4, tí econometrician bá fẹ́ ṣe analysis tó fẹ́ ṣiṣẹ́, á sọ lórí hypothesis àbí economic theory. Ìyẹn ló kọ́kọ́ fẹ́ prove, right? Bóyá ká sọ pé okay o, ẹ̀ ń wo impact of government spending on education, impact of government spending on education on the economic development of Nigeria. Impact of government spending on education on the economic development of Nigeria. So kí ni hypothesis yìí máa jẹ́? Hypothesis yìí máa jẹ́ there is a relationship between there is a positive relationship àbí an increase in government spending on education improves what do they call it now? Improves the economic development of Nigeria. So ìyẹn ló máa ń pè ní your first hypothesis, right? So ìyẹn lẹ fẹ́ test by ẹ máa bẹ̀rẹ̀ sí máa gba data lórí government spending on education for different years, maybe almost like at least about 30 years. Ẹ máa gba data náà lórí economic development of Nigeria. So kí lẹ fẹ́ fi proxy, like torí kò sí nǹkan tó ń jẹ́ economic development as a variable. So kí lẹ fẹ́ lò? Ó lè jẹ́ bí GDP lẹ fẹ́ lò, àbí GNP, àbí GDP per capita, nǹkan kan bẹ́ẹ̀ yẹn. Ó lè jẹ́ pé nǹkan tẹ fẹ́ lò nìyẹn. So ẹ máa state yẹn náà pé okay, máa lo GDP per capita, máa lo human development index, máa lo variable by. So àwọn ló máa jẹ́ independent variables yín pẹ̀lú dependent variable. So like those are the things tó ń sọ nípa obtaining data. So you obtain your data. And after you've now obtained your data, kí lẹ máa ṣe? Number 5, ó wá ní estimation of the econometric model. Eléyìí ọwọ́ kọ́ lẹ máa fi ṣe. Although bàbá ṣe ń kọ́ ẹ̀kọ́ ẹ lọ, ẹ máa rí bí tẹ́ ti lè fọwọ́ ṣe. Ẹ máa rí àwọn equation tẹ́ lè lò. Tẹ́ máa fi solve formula, tẹ́ máa fi solve out. Gbọ́dọ̀ kì í ṣe formula kékeré, but at least for simple regression analysis, the formula is not a big deal. So a máa ṣe àwọn maths ẹ̀ náà, so like ẹ máa wà okay ṣá. So estimation of the econometric model. So we said we can do it manually, but then in the real world nobody does it manually. Ẹ kàn máa tẹ̀ sínú bóyá Excel lẹ fẹ́ lò ní o, bóyá àwọn statistical kí ló ń pè, statistical softwares, e-views, SPSS, nǹkan kan bẹ́ẹ̀ yẹn. So bí àwọn kan yẹn lè fẹ́ lò, ẹ kàn máa kó àwọn data yẹn, ẹ máa dà sínú ẹ máa import ẹ̀ sínú ẹ̀, then you run a regression analysis. Òun ló máa ṣe, á dẹ̀ gbé result jáde fún yín. So result tó máa wá gbé jáde, ó máa jọ result tó wà ní níbo lọ́kọ́ sí ẹ̀ náà. Mo fẹ́ ká wo number 5, estimation of econometric model. So since obtaining the data, we have the data we needed. Our next point of action is to estimate the parameters. Our B1 and B2 yẹn, estimate the parameters of the consumption function. Since the consumption la fi ṣe àpẹẹrẹ. Now the numerical estimates of the parameters give empirical content to the consumption function. So this is also an example of bí econometrics ṣe yàtọ̀ sí economic theory, because economic theory ò ní fún yín ní number. Now, the actual mechanism of estimating the parameters will be discussed later in this course. Because them not so non later near, so like I'm not bother. However, note that the statistical technique of regression analysis is the main tool used to obtain the estimate. For example, assuming the data collected was subjected to calculation, I will obtain the following estimate. So B1 and B2. So B1 lè fún ní -144.06 ìgbà tẹ́ ti gbé sínú kọ̀ǹpútà tóun ti run ẹ̀. Ṣàfihàn pé B1 based on data tẹ́ fún un, because oríṣiríṣi data tẹ́ bá ń fún ó máa fún yín different results fún gbogbo ẹ̀. So B1 is equal to -144.06. B2 is equal to 0.828282. So the estimated consumption function over òun wá lélẹ̀ báyìí. Y kíní tó wà lórí Y yẹn ẹ mọ̀ pé kíní kan wà lórí I kó dé adé ìmọ̀ bí ẹ notice ẹ̀. So wọ́n pè ní Y hat, like HAT, like a hat, HAT, Y hat, people there, Y hat is equal to minus, well, kíní tán is equal to -144.06 plus 0.82x. X lẹ́kọ̀ọ́ wà bẹ́ẹ̀. As you understand bẹ́ẹ̀. So Y hat is equal to -144.06 plus model kìíní là ń fọ model tó wà ní equation 2 là ń follow. Ibi tó ti sọ pé y1 is equal to b1 plus b2x plus u. So a kàn máa substitute àwọn number tá a gbà, so a kàn máa fi exchange ẹ̀ fún b1 and b2. So that was just nǹkan tó kàn ṣẹlẹ̀ bẹ́ẹ̀ nìyẹn. So reason tó dẹ̀ fi lo y hat ni pé a máa sọ lórí ẹ̀ later ṣá. So the y is like the true value tó yẹ pé òun lẹ́kẹ̀ẹ́ gbà, but a y hat is estimated value ní y hat estimated value. So nítorí wọ́n ti kọ́ sẹ́yìn àbí okay estimated consumption function so the estimated consumption òun ni y hat. So bá tó fi ń pè ní estimated nítorí pé error term wà ń bẹ̀. So for the fact that there is going to be an error term, so the estimated value is not going to be equal to the true value. Kò ní jẹ́ the exact value tó yẹ kẹ́ gbà in the real world. Ṣé ti understand bẹ́ẹ̀? Òun ló ṣe ń lo y hat fún. Okay. So that okay means I got fi hat kan síbi. The hat on the y indicated that it is an estimate. The estimated consumption function, that is the regression line, is now shown below. Gbogbo àwọn kìíní náà like bàbá ṣe ń kọ́ ẹ̀kọ́ ẹ̀ lọ lẹ ṣe máa understand ẹ̀. So regression line, by the time tẹ́ bá ti da gbogbo data yẹn sínú software, ó máa generate regression line. Tó bá ti solve ẹ̀ tán, there is a way you can check for the regression line. So máa generate regression line yẹn fún yín. So tẹ́ bá rí bíbá yín sìn, dọ́ọ̀tì méjì péré ló fall sórí line tó díà. Nínú dọ́ọ̀tì mélòó? 1 2 3 4 dọ́ọ̀tì mélòó ló wà níbí báyìí mà? 12. 11 lèmi kà o, àbí mo ní number 12 wá? Ẹ̀hẹ́n 11. So nínú 11 yẹn, only 2 of them ló wà exactly on the line. Gbogbo àwọn tó kù yẹn wọ́n jìnnà díẹ̀. So error term gbogbo àwọn kíní ẹ̀ bẹ́ẹ̀ yẹn. Ṣé ti understand? Àwọn tí ò fall sórí line, gbogbo ètò fall sórí line yẹn, error term wọn 0 ló máa jẹ́, like kò sí error, like ó wà perfect. Wọ́n ṣe gbogbo àwọn tí ò fall sórí line yẹn, wọ́n máa ní error term. So nǹkan míì ló fà á tí wọ́n ṣe behave exactly as the way they are supposed to behave. So for you to know if your regression line is very, very okay, most of those dots must fall on the regression line. Irú eléyìí regression tó yẹ pé èèyàn ṣe project ó wá ṣe regression wá fún ní result báyìí, result eléyìí ò dáa o torí pé méjì péré ló fall sórí line yẹn. So nínú nǹkan bí 11 àti jẹ́ kí 6 or 7 kó fall sórí line yẹn gangan láti fi show pé okay data tó lò fún analysis yìí data ẹ̀ pé ó make sense, ó wà reflect nǹkan tó ń ṣẹlẹ̀ nínú economic theory yẹn. But nínú eléyìí sìn 2/11 la gbà yìí náà, 2/11 F9 nìyẹn. Like, she understand ma? All right. So you have GDP, you have personal consumption expenditure on a PCE tó wà níbí. Personal consumption expenditure. So you have different level of GDP, different level of consumption for different households. So when we are now done with that, so mo fẹ́ kẹ́ tún recap àwọn 5 steps báyìí. So ká máa ṣe ń ṣe lẹ́ẹ̀kan kẹ́ tún recap àwọn 5 steps yẹn. Okay, or economic theory. Stating of economic theory or hypothesis, number one. Thank you, ma. Yes. Econometric model. Econometric. Okay. Obtain your data exactly. Then you perform estimate the data exactly. Estimate the economic model. Estimate the econometric model exactly. So tẹ́ bá ti estimate ẹ̀ tán, the next thing is now hypothesis testing. Okay, ẹ ti gba results. Hypothesis sọ pé okay o, tí income bá increase, consumption spending náà ó yẹ kó increase àbí? Tẹ́ bá rántí macro tá a ṣe. So ẹ wá fẹ́ lọ test hypothesis yẹn, ẹ wá wo ẹ wo equation 3 yín. Mo sọ pé tá a fọwọ́ kọ dáadáa ni ó yẹ kó jẹ́ y is equal to -144.06 plus 0.862 then x níbi tí x jẹ́ income. GDP ni wọ́n fi proxy income bí báyìí, GDP ni wọ́n lò lọ́ fi proxy income. A proxy is a variable that you use to like measure another variable if you don't have that exact variable. Tẹ́ bá ní data lórí that exact variable, so variable lẹ lè fi approximate yẹ lẹ lè lò instead of. Ṣé ti understand ma? Hello ma. Mo ń sọ lórí proxy variable. Proxy variable PROXY. Mo ní proxy variable is a variable that is used. Ẹ lè kọ́. Ẹ lè gbé tí ń wọ ìgbádùn mood. Okay. All right, man. All right, so mo ti fi sínú chat box already. So a variable that is used to like capture another variable. If the initial variable does not have like data that you can use or does not have enough data that you can use. So for example, if you real GDP, data will real GDP for any country. So if you real GDP, if you measure national income, and if you real GDP, if you measure economic growth, so it is a proxy variable. So ibi tí kò ti sí variable gangan tó ń jẹ́ economic growth tẹ́lẹ̀ rí data lórí ẹ̀. So ẹ lókè ẹ ká fi real GDP ṣe replacement fún kí ló ń pè economic growth. So I was saying that if they had written this thing well, should have been y is equal to -144.06 plus 0.8262 then x. So from that, kí ni MPC? Nínú ibẹ̀ kí ni MPC? 0.83. Exactly. No, 8262 83 náà ni 0.83 náà ni. So that's our MPC. She understand a lot of shit. So you can really like flow with all of these things. So the MPC here is like 0.82 whatever. So which is saying that the hypothesis is correct in the sense that an increase in the income will cause an increase in consumption. So because agba nǹkan MPC tagba is a positive number, ẹ̀dẹ̀ rántí pé MPC ò lè jẹ́ minus, tagba MPC lọ jẹ́ minus nísìnyí a máa pa kíní tá a ṣe kò correct o, hypothesis wa ò correct o, based on data tá à ń wò ńlẹ̀ yìí o kò correct. Ẹ ti understand? Exactly, between 0 and 1, exactly. So kí ni autonomous consumption? Ní bíbá nínú equation kí ni autonomous consumption? Equation 3 page 22 ló wà níbí báyìí. MPC nìyẹn, mo ní kí ni autonomous consumption. Exactly, minus 144.06. So in economic term, right, this is not correct. Mo ń gbọ́ yín, ṣẹ́yìn gbọ́ mi? Mo ń gbọ́ yín. Yeah, that's correct. So mo wá sọ pé in economic term, according to economic theory, this is not correct because ẹ̀ka àgbà kan nìyẹn. Because àmọ́ pé autonomous consumption òun ò kí negative, kò dẹ̀ kí ń jẹ́ 0, it should be a positive number. So ẹ ti rí bí àwọn understanding of economic theory bó ṣe ń wọnú econometrics bẹ́ẹ̀ yẹn. So téèyàn bá ti ní result báyìí, so ó jẹ́ pé okay bóyá data tó gbà bí ó ní problem, àbí bóyá data tó téèyàn lò téèyàn fi ṣe analysis, bóyá data yẹn ní problem, àbí data yẹn ò pọ̀ tó. As you understand, something is wrong with that data because the result is not following economic theory, or maybe the economic theory is wrong. So bí wọ́n ṣe máa wò nìyẹn, bí wọ́n ṣe máa sọ àwọn application yẹn nìyẹn. So níbi ìsìn wọ́n máa ní okay o, if income should increase by 1 naira, we expect consumption on average to increase by 0.8262. Income, as you understand the interpretation here, income by increase by 1 naira, consumption would increase by 0.862 on average. A máa fi average sí because data yẹn kì í ṣe data ẹnìkan. A kàn wo ìwé tá a bá bẹ̀rẹ̀ regression ṣá, we understand. So this is saying that the graph is showing personal consumption expenditure in relation to GDP from 1682 to 1996. Kí ló dẹ̀ wá dé? Kí ló ń jẹ́ 1682? Maybe 1982 ni wọ́n fẹ́ sọ. Èwo 1682? How many years? So 1982 mo fi pè é kó jẹ́. So bá ṣe ń fi ojú wo yẹn ṣe àti fi style òpó òkè ṣe hypothesis wa ṣe ó correct. But then there are now statistical tools that you can also use to know if your hypothesis is right or wrong. Ìyẹn tó bá bẹ̀rẹ̀ sí máa ṣe regression like proper, ẹ máa rí bẹ́ẹ̀ ṣe máa mọ̀ pé hypothesis yìí o. Because sometimes a lè gba model tó fi pé okay model yìí correct, autonomous consumption wa tó bá pé consumption function á ṣe lé lórí, autonomous consumption máa jẹ́ positive number. MPC ó máa between 0 and 1. But then it may not even be correct. The model may be far from reality. So àmọ́ abẹ́rẹ́ sí máa wo ṣe hypothesis testing láti fi sure pé model yìí ó ní àwọn formula láti máa bẹ̀rẹ̀ sí máa lò nǹkan kan ṣá láti fi rí pé okay this model is correct. So coming to talk about hypothesis testing proper, and most of number 6 by assuming that the fitted model, which is the regression line, is a reasonably good approximation of reality, and the fitted model here is from the data tag bar. Okay, my line, sign dotted lines, my line consider. So we have to develop a suitable criteria to find whether the estimates obtained in equation 3 are in accord with the expectations of the theory that is being tested. Now, according to positive economists like Milton Friedman, a theory of hypothesis that is not verifiable by appeal to empirical evidence may not be admissible as a part of scientific theory, in the sense that whatever theory that you are doing, you can only means of verifying that the theory is appropriate. So as noted by Keynes, the MPC is meant to be positive but less than 1. So tẹ́ bá rí equation 3, the MPC is 0.083. So eléyìí tí ń fi style for an indication pé okay o, this thing is kind of correct. But before we accept this finding as confirmation of Keynesian consumption theory, we must inquire whether this estimate is sufficiently below unity. Unity is 1. Okay, only kókó lè jẹ́ 1. So we want to know say it is, I'm okay it is below 1, but like is it sufficiently below 1? Like is it a perfect figure that we are supposed to get, or is it a true figure, a realistic figure that we are supposed to be getting? Okay, 0.083 ó below 1. 0.092 yẹn náà wà below 1. You understand? So like we want to test, okay, ṣé 0.083 ṣé òun ló yẹ ká really gbà of all the numbers that we know that could be between 0 and 1. So yẹn ni hypothesis testing. Ó dẹ̀ ní different hypothesis techniques that you will in later chapters mo rí pé ó ti wà ní material yẹn already. So but before we accept this finding as confirmation kinikan, so we want to know in conclusion, is 0.83 statistically less than 1? So if you are looking at statistical significance, ìyẹn náà a máa mọ̀ like later. So nǹkan statistical significance bí wọ́n ṣe lè ṣàlàyé ẹ̀ díẹ̀díẹ̀ ni pé okay for example manufacture oògùn tẹ̀ fi pé okay oògùn yìí lè cure cancer. So okay, statistical significance ọ̀nà mẹ́ta ló pín sí. There is 1% level of significance, there is 5% level of significance, there is 10% level of significance. Now as a way of trying to like understand it, 1% mean pé a fi àyè fún 1% error. Pé tẹ́ bá fún èèyàn 100 ní oògùn yìí, 99 of them ó máa yè. So like that's one way to like use that to like understand statistical significance. So at 1% level of significance, I expect okay error ẹyọ kan ló máa wà pé ẹnìkan pé ní ò ní ṣiṣẹ́ fún 99 people are going to be okay. Now tá a bá ń wo lórí 5% level of significance, 95 people are going to be okay. 5 people is not going to work. The drug is not going to work for 5 people. And the man in 10% level of significance, 90 people will be fine. 10% of them will not be fine. So like that's one way to like understand. So like the acceptable level of significance is 1, 5, and 10. And to be very honest, but can really feel low below 5%. But 5% is enough risk. Like me, whatever understand, Ben. So there is a way to test it. I put it my breast my probability values, my critical values, but so what we are just trying to like know from here is that we test our hypothesis to know based on the results from our model to check if the parameters are statistically significant. So like that's just what you want to do under hypothesis testing. Whether the numbers themselves are looking as if they are in accordance with the theory, or they are looking as if they are at variance with the theory, hypothesis testing. So this one náà a lè fi ọwọ́ ṣe, but mi mọ̀ reason tó fi máa sọ pé ká máa fọwọ́ ṣe káàkiri because software ló yẹ kó ṣe, interpretation ló yẹ ká máa kọ́ school, but wọ́n sì máa fẹ́ ká máa ṣe bó ṣe ń fi ọwọ́ calculate gbogbo àwọn kíní yìí. It is well with our souls. Number 7 wá ní tẹ́ bá ti ṣe hypothesis tẹ́ tí wá rò pé okay this thing is actually correct. Okay, this model that we've obtained after doing our hypothesis based on the data that we have, this model is true, is what we are supposed to have. So a lè wá fi model yẹn máa fi ṣe forecast àbí ká máa fi ṣe prediction. Now what do I mean? Wọ́n ti wá kọ model yẹn properly sí page 23 under forecasting or prediction. Ṣé ẹ̀ ń rí mà? So we have 1997. The consumption function is the function minus 144 kinikon x. So we can now say okay, if GDP or if income is a particular value, what should be our consumption expenditure on average? If GDP is a particular value, what should be our consumption expenditure on average? So níbi àyín sí a fẹ́ predict ni, a fẹ́ predict ìpè okay o tí GDP bá jẹ́ 6158.7, kí la expect pé kí consumption jẹ́ on average. Reason tó dẹ̀ máa fi ṣe kíní is because of policy implementation. Ìjọba lè fẹ́ wò pé okay o a fẹ́ raise the consumption spending àwọn èèyàn, but a fẹ́ target yẹ okay àwa fi pé okay o tá bá ní pé okay kí la lè fi raise consumption wọn ẹ̀ka reduce the taxes wọn, like their taxes on their personal income. Let us reduce their taxes. So if you reduce their taxes, um, their income is going to like disposable income is going to increase. To bá dẹ̀ increase, consumption spending wọn máa increase. But àwọn ohun kankan, tá bá reduce taxes wọn in a way that disposable income wọn máa jẹ́ 6158.7, kí la expect pé ó yẹ kí consumption wọn jẹ́ on average? Because in this kind of thing now, ó lè jẹ́ bí a recession ní economy wà, government ń try to boost the economy from recession to economic growth. Ó fẹ́ káwọn èèyàn bẹ̀rẹ̀ sí ní máa spend. So the government is looking at it, okay, if we should make their income to like increase to this particular amount, is this sufficient enough to push the economy away from recession? So, but they cannot do that except they first done estimation based on data that is available. So estimation ti fún wa ní results. Àwa fẹ́ ṣe prediction àbí forecasting àbí whatever forecasting nísìn. So X is assumed to be a value. Ẹ̀dẹ̀ mọ̀ pé X ní independent variable náà tẹ́lẹ̀tẹ́lẹ̀. It just has a value that nothing can explain. A kò assume ẹ̀ náà ni. It's assumed to be okay 6.58 points kìíní kan. Ó wá gbé sínú model yẹn. And at the end of the day, it is going to be giving us a value. Value wọn bí báyìí kò yẹ kó ní minus. This value is not correct. It is supposed to just be 4944.25. Tẹ́ bá wò dáadáa, because minus 144 lẹ́fẹ̀ẹ́ yọ kúrò ní 5,000 and something. Tẹ́ bá fẹ́ yọ minus 144 kúrò ní 5,000 and something, kò yẹ kó máa fún wa ní minus 4,000 kìíní kan. So yẹ kí 4,000 yẹn dá dúró ní 4944 lẹ́ kó jẹ́ mi bẹ̀yẹn, so like ẹ lè cancel ẹ̀. Kò yẹ kó ní minus. So this is now saying that if the model we choose does not refute the hypothesis or theory under consideration based on our hypothesis testing, we may use it to predict the future values of the dependent or the forecast variable y of the dependent or forecast variable y on the basis of known or expected future values of the explanatory or predictor variable. Ẹ rí pé àwọn ò sọ̀rọ̀ predictor yìí o, èmi mo kàn dárúkọ ẹ̀ lẹ́ẹ̀kan yẹn pé a lè pè ní predictor. Ẹ̀gbọ́n ti lo predictor kan ti ra gbé wọlé bẹ́ẹ̀ soft. Ẹnìkan máa wá nǹkan tó ń jẹ́ predictor káàkiri. So let us make use of equation 3 as an example. Suppose we want to predict the main consumption function for 1997. The GDP value for 1997, for example, say is $658.7 billion. Putting this GDP figure on the right side of the equation, so we are getting a consumption on average of about 4,944 billion naira. So thus giving the value of the GDP, the mean or average, because it's really important in regression analysis. Average là ń wá, because the buy increase the GDP by that particular amount. Kì í ṣe fún everybody ní consumption wọn máa increase by 4,944 point kìíní kan. Àwọn consumption wọn máa jù bẹ́ẹ̀ lọ, àwọn consumption wọn máa lower jù bẹ́ẹ̀ lọ. But we are looking at the mean value. Àtàwọn tó jù bẹ́ẹ̀ lọ, àtàwọn tó jẹ́ the same value, àtàwọn tó wà lọ́ndà a kó wọn papọ̀, àwa find the average wọn. So the average value is this. Right? So the consumption value, given the GDP, given the value of the GDP, the mean or average forecast consumption expenditure is about 4,944 billion naira. So the actual value of the consumption expenditure reported for 1997 was 4,913.5 billion. So àwọn kan tó ṣẹlẹ̀ níbàyẹn sí, wọ́n lo data, wọ́n estimate regression function, and based on that regression function, wọ́n wá predict pé okay ní ọjọ́ iwájú ní 1997 no, tí GDP bá jẹ́ iye báyìí, consumption wa ó yẹ kó jẹ́ 4,944 billion. But by the time they got to 1997, exactly, consumption in 1997 was 4,913.5 billion. So ṣé ẹ feel pé prediction tí model yẹn make pẹ̀lú reality pé a lè sọ pé a lè mark ẹ̀ pé ó correct àbí ká sọ pé ó wrong? Mo ń béèrè ìbéèrè ni mà. $4 billion naira. No, what predict 4944? Mọ̀gán tí wọ́n padà rí lọ́dún ẹ̀ was 4913. Like kí lè tẹ́ bá fẹ́ mark accuracy kìíní yẹn, irú mark lè fún tẹ́lẹ̀ pé prediction yẹn pé ó jẹ́ nǹkan tí wọ́n lè rely lé lórí ọ̀ nǹkan tí mo fẹ́ gbọ́ nìyẹn. Was it close? Àbí it was far? So 4,944 billion àti 4,913 billion ó jìnà. Yeah, exactly. Bẹ́ẹ̀ ṣe ń wò ó nìyẹn 44 30. So like ó jìnnà by 29 million naira kọ́ nìyẹn. Òun náà pọ̀. But well, but yeah, that's true. That's true. Òun náà pọ̀. But then, to me, I can still say that it is still close. It was still a reasonable prediction. To me, it's still a reasonable prediction. Tẹ́ bá approximate àwọn méjì sí the nearest 100, it is saying this is like four. Ma? Exactly. So méjì, exactly. Méjì máa jẹ́ 4900. So like it is still like a very like close prediction. Still a very close prediction. So but then, if we look at it, the estimated model in equation 3 does over predicted the actual consumption expenditure by about 30.76 billion naira. 30.76 billion naira. So since ẹ pé nǹkan tí prediction wa jẹ́ ó ju iye tí a padà rí lọ, so láti pé okay, ó over predict by about 30.76 billion naira. So we could say that the forecast error, so because error ti wà ń bẹ́ẹ̀ nìyẹn, kò jẹ́ the same thing gangan. The forecast error is about 30.76 billion naira, which is 0.7% of the actual GDP for 1997. So in fact, the forecast error was not up to 1%. Mi mọ̀ tẹ́ bá understand nǹkan tí mo sọ bẹ́ẹ̀ yẹn. Kò wọ́n 1%. The forecast error was not up to 1%. So it is still, to me, it is still moderate. But ó tún wá depend lórí nǹkan téèyàn wá ń wá gangan. So tí nǹkan bá sọ pé èèyàn 4913.5 ni ó máa bí ló máa ṣaláìsí based on a particular thing, téèyàn 4944 wá lọ ṣaláìsí. So in that context, ó ti pọ̀ jù. Ó ti pọ̀ jù. So it depends. But like normally, mathematically speaking, the forecast error is 30.76 billion. That is our model. It's over. Its forecast was more than what the actual value was. So it's over. Language hotel all no. It's language control. It over-reported the 1997 value. It over-reported 1995. Torí pé ó pọ̀ jù lọ ṣe pè ní over-reported. Now, number 8, uses of the model for control or policy purpose. Mo ti ṣàlàyé eléyìí gan actually, but then let's just proceed. So let us assume that we have already estimated the consumption function given in equation 3. Suppose further that the government believes that consumer expenditure of about 4,900 billion naira in 1992 will keep the unemployment rate at its current level of 4.2%. So government will go, okay, tí GDP bá jẹ́ tí consumption bá jẹ́ 4,900 billion, unemployment rate kò ní ju 4.2% lọ. So what level of income will you guarantee the target amount of consumption expenditure? What level of income? So the thing is, wọ́n fẹ́ maintain ní consumption yẹn sí 4,900, right? Or nísìnyí, the first one tá a ṣe, which is for prediction or for forecasting, a ní value for independent variable. I want to try to see more the future value of the dependent variable. But níbi báyìí sìn, ní control purpose, àti more value of the future, àti more future value, like àti estimate okay, future value tá fẹ́ gbà lélẹ̀. So like this is like consumption targeting. Ẹ̀tí target pé this is the value that we want for consumption. So iye income èlò ni àwa lè work towards tó máa jẹ́ kí a kò rọra máa ní this value for consumption expenditure exactly. A fẹ́ ní ju báyìí lọ, 4.2 unemployment rate ta ní ó tẹ́ wa lọ́rùn. A fẹ́ ju bẹ́ẹ̀ lọ, a dẹ̀ fẹ́ like a fẹ́ kó tún kéré náà ju bẹ́ẹ̀ lọ. So what amount of income or GDP do we need to maintain this level of consumption expenditure so as to maintain the level of unemployment that we have? So níbẹ̀ ẹ̀sìn wọ́n ti mọ nǹkan tí wọ́n work to, which is 4,900. So ẹ̀kan máa ṣe normal calculation náà ni. So níbi by ẹ ti mọ dependent variable, so it's just like solving for x tí ẹ̀ máa ṣe normally. Ṣé ẹ follow ma? Alright, so just solving for x. So níbi ẹ ti ní 4,900, 4,900 is equal to 144.06 plus whatever kìnnìkan. Màtẹ́lẹ̀ solve ẹ̀ jáde, the value gave them 6,105 billion. 6,105 billion. So to keep consumption at 4,900, you need an income level of 6,105 billion naira. So ẹ ti ń rí àwọn applied application of mo ní applied application applied part of econometrics. So ibi eléyìí ti ń ju statistics lọ bẹ́ẹ̀ ẹ ti ń apply to real life. So you've estimated your consumption function and then you are now using it to make forecast or to like to have or for policy purpose for policy control or policy control. So from the analysis above, an estimated model may be used for control or for policy purposes. By appropriate fiscal and monetary policy mix, the government can manipulate the control variable to produce the desired level of target variable y. Ṣé mo also mention pé dependent variable is also called control variable? Ẹ lè add ẹ̀ náà mọ́. Dependent variable is also called the control variable. And the independent variable, control variable. And then the independent variable, ìyẹn controlled variable yẹ kí yẹn jẹ́. Ìyẹn la máa adjust. Let me verify to be very sure. Control variable is a variable that is held constant in a research study. Okay, independent variable ni control variable. Independent ni so mo ti ẹ bá mi change ẹ padà. Independent variable ló ń pè ní control variable. Variable that is held constant in a research. Yeah, it is independent variable. All right. So like proceeding from there, we now nǹkan tá a fẹ́ ṣe náà ti tán náà dẹ̀ nìyẹn. So in summary, only discuss the 4 stages of econometrics. There are more than 4. 8 stages ló wà níbí báyìí now. Èwo ni 4 stages? Àbí ṣé nǹkan tó wà nínú material yín lọ́dọ̀ níbẹ̀ náà nìyẹn? A ti ń sọ̀rọ̀ lórí question ma. The 4 stages of econometrics. Okay. Exactly, and traditional stage that kind. Yeah. So like Egbudo Momo in that form, like it's not even difficult to memorize. It's not difficult to memorize. Like Egbudo Momo in that form, from your hypothesis or your economic theory to your writing of mathematical model to the writing of econometric model, on and on like that until you get to prediction and control for policy control. Like you need to like know them in that way. Kí lẹ sọ? Okay. Mo tún lọ mọ àwọn question bí àkọ́kọ́ wà nínú ẹ̀ tá ti ṣe. Explain the use of econometrics for assessing economic models. Hypothesis test náà ló yẹ kí lè jẹ́ for assessing. No, kí ni mò ń wò o? The exam question tẹ́ send sí mi yẹn ni mò ń wò. Question 4A. Explain the use of econometrics for assessing economic models. Assessing is like evaluating. So I think hypothesis testing really, to me, I'm looking at it as a form of hypothesis testing. Sherry, this particular exam, gbogbo question to work béèrè hypothesis testing ní gbogbo ẹ̀ wà. Like one topic, which is sad. It's very very sad. B nìkan ni ò kí ń ṣe from hypothesis testing. Má lè ṣe máa set irú exam báyìí. Ṣé ẹni tí ó bá ka hypothesis testing kò mọ̀ ọ́n kan nìyẹn. Are we still together, ma? You have left me behind, cha. I thought you. Okay, okay, ó ti dáa. So then no, 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 I was not insulting your school. Oh, I was not insulting your school. I was saying no. What I was saying was that topic ẹ̀yọ̀ kan péré ni wọ́n ti lọ set gbogbo exam, and that's actually not that's it, and that's even wrong. Like it's because of our yeah, it's because of our anyhowness in Nigeria. Sha. Like in terms of educational standard, international educational standard, that is wrong. Because ẹlòmíì gan lè kà kó má yé, so you should be able to give students options. Ẹ ti understand bẹ́ẹ̀? Ẹ lè ṣe ní compulsory question o. Like ó yẹ kí àwọn other ones wà tí student lè ṣe. So like it is in education it is wrong. But then anyhowness wà ní country yìí ó pọ̀ gan. So it is well. Now computer and econometrics. Ah, can you imagine? Can you imagine? Can you imagine? Oh, yeah, of course. Ó ní agbára. Ó ní agbára. Ṣáà mọ gbogbo ẹ̀. It is well. Al- All right, so here we are now looking at computer and econometrics at one unit 3. So mo fẹ́ mọ̀ bóyá iná wà on the same page. A kàn máa ṣe díẹ̀ náà ní ká tó fi pàdé sí ọjọ́ mi. Are you there, ma? So that we can. Okay. Ah, nǹkan tó wà níbà ẹ̀kọ́ nìyẹn o. Machine learning. Ah, machine learning yẹn jìnnà. No. Topic tí mo fẹ́ kẹ́ ẹ wò. Ṣé topic yẹn lẹ wà? Uses of computers in economic analysis and forecasting. Uses of topic yẹn nìyẹn. Uses no, no, computer and econometrics. Ẹ lọ wà nínú slide yín computer nínú material computer and econometrics. Machine learning tẹ́ ẹ̀ sọ yẹn. Ah, nǹkan tó wà níbí báyìí forecasting approaches to forecasting matching situations with forecasting methods 6 important characteristics of dimensions kìnìkan kìnìkan. Kò sáwọn machine learning yẹn bí o. So wo náà mo ti rí machine learning. So machine learning wà ní 3.8 machine learning wà ní 3.8 níbí báyìí differences between econometrics modeling and machine learning. Ẹ níyàn àbí? Differences between econometrics modeling and machine learning. Ẹ̀yẹn wà nínú ilé náà. Ẹ bá mi kí ló bẹ̀rẹ̀ computer and econometrics ọ̀dọ̀ yín bẹ́ẹ̀? Okay. Okay, mo ń bọ̀. Kínní nìyẹn wà 3.6 nìyẹn wà níbí báyìí. 3.6 ló wà níbí báyìí. So like àwọn tiẹ̀ wọ́n á yẹ pé wọ́n kò sí nǹkan kan nínú kọ̀ǹpútà ìbá kọ̀ǹpútà rárá nínú slide tó wà nínú material tó wà lọ́wọ́ yín. Nǹkan tó fi bẹ̀rẹ̀ ọ̀dẹ̀ wa bẹ̀rẹ̀ láti types of econometrics. Òun ni types of econometrics àbí? material tó máa ń bí gbóǹgọ́ tẹ sọ́n sínsìn gbóǹgọ́ tẹ sọ́n sínsìn ló wà nù ilé gbóǹgọ́ tẹ sọ́n sínsìn ló wà nù ilé but the computer kìíní okay arrangement ni okay okay me see reparting me see reparting but let's go to the part that we are that are the same thing. No, and people say anything that like main content in by. Okay. The any regression analysis, the bread and butter tool, abi. I've seen 3.5. Okay. So regression analysis, the bread and butter leko gel, the bread and butter tool of econometrics these days is unthinkable without the computer and some access to statistical software. So mi ò mọ reason tá a fi ń fi ọwọ́ ṣe nǹkan tẹ́ kọ̀ǹpútà máa ṣe. So however, several excellent regression packages are commercially available, both for the mainframe and the microcomputer. And the lot is growing day by day. So to tell us that there are so many statistical softwares. So tó máa ṣe nǹkan tẹ́ fẹ́ kẹ́ ẹ ṣe. Our regression softwares they include Momo SPSS, eViews, ló wà mí kì í ṣe eVents, View, so eViews, Momo Stata, mi ò mọ SAS tó fi síbí. So all of these they are packages, statistical packages to run regression analysis. They are just to help you like analyze your data. eViews, eViews. Yeah. Yes, EWS, eViews. So there are few of the economic software packages used in conducting estimation analysis on economic equation and models. So you have them in kí ló ń pè é? Python wà, èwo ló tún wà náà? Wọ́n ṣàpọ̀, wọ́n pọ̀ bẹ́ẹ̀ téèyàn lè lò. Excel gan máa ṣì ń ṣe some of these things too. Excel náà máa ṣe some of these things. So computers are used in the creation of complex forecasting models, as in computational finance, computer simulations and models can be used to predict how markets will change. Gbogbo àwọn tó máa ń ṣe stock market, finance nǹkan yẹn, àwọn kọ̀ǹpútà iná ló máa ń lò. Gbogbo àwọn machine learning tí wọ́n ń ṣe tó fi jẹ́ pé tí ẹ bá fẹ́ tá bá sọ̀rọ̀ gan sìn, bàtà tí bá bẹ̀rẹ̀ sí wo YouTube, tẹ́ wo Facebook, nǹkan tá a sọ yẹn lọ́wọ́ máa recommend fún yín. Àwọn ní kẹ́ wá rà. Ẹ̀yin ẹ sọ pé ibi ń pa yín sí, kò ní pẹ́ ẹ kàn máa rí nǹkan lórí restaurant, oúnjẹ nǹkan kan lọ́wọ́ recommend fún yín. So gbogbo àwọn kíni ẹ̀ computers lọ́ fi ń ṣe, they are gathering data, they are analyzing data, and based on those data wọ́n rí àwọn consumer preferences and wọ́n wá recommend fún automatically nearest shop that you can get those things. It is based on data that we are given from our communication. So they are stealing our data, and that's just the point. Are using them to make recommendations to us. Now, computers are used in creation of complex forecasting models. They call it a day. So computational finance, what else? It offers good facilities for the analysis of cross-section and panel data. So what is a cross-section data? What is a cross-section data? A cross-section data is a data that contains different variables. Cross-sectional data. Ṣé wọ́n define ẹ̀ fún yín bẹ́ẹ̀ ni? Jẹ́ kí n má worry mọ́ ni. Okay. So cross-sectional data, cross-section. Oh, one material, you know, ẹ but well, define it. So I'm just telling you. Cross-sectional data is a data that contains different variables at the same time period. You know, yeah. Yeah, you know, yeah. So I guess we can at the same time period. And then mo ń try láti wá example tí mo lè send sí date prediction input kiniko kiniko. So there's this one. I'll send you some images, Sha, to see examples of cross-sectional data. So the same year ló máa máa wò, but then different variables. Wà á ní cross-sectional data ló máa wà ń bẹ̀. So that being said, then there's a panel data. Ìyẹn máa máa wo different variables is a data that contains different variables at different time periods. Different variables at different time periods. So cross-sectional, this one is a cross-sectional data. So which in column and different variables at different time periods. Well, then after that, àwa ní in economics, a cross-sectional data contains ó mà ti padà fi síbẹ̀ mí dẹ̀ mọ̀ ṣá. A cross-sectional data contains data on collection of economic agents at a given point in time. Àwọn economic agents yẹn náà náà ń pè ní, we know them, firms, households, governments and the rest of the world. So data on anything tẹ́ bá ń ṣe, bí ẹ fẹ́ gba GDP ni o, ẹ fẹ́ gba income ni, ẹ fẹ́ gba consumption ni, but it's at the same period of time, 2004 or 2005, ẹ wá gbé oríṣiríṣi data for that particular year. It is also used for a more accurate prediction of some key variables and for a more detailed look into the future. Economists turn to computerized econometric forecasting models. Well, ẹ ká fi pàdé sí ibi báyìí. We'll continue from there tomorrow by God's grace. Mi mọ̀ tẹ́ bá ní ìbéèrè. Okay, a máa ń ta àwọn courses yẹn ni, so a kì í release gbogbo ẹ̀. So ẹni tó bá ti wo díẹ̀, tó bá ní pé òun fẹ́, òun ní interest, á dẹ̀ comment, á dẹ̀ máa wá, àbí kó reach out sí wa ní WhatsApp, á dẹ̀ máa ta. But ẹ̀yin ò ní interest nínú kẹ́ ra courses, ẹ lọ wá ẹ tó kún ṣe courses fúnra rẹ̀. Báwọn olówó ṣe máa ń move tiwọn nìyẹn. So I will share with you. I'll share with you. All right, man. See you tomorrow by God's grace. You're welcome, man.